So hey guys, welcome back to a new video. In the last video we looked upon the Bohr atomic model. Yes, there have been a series in which we have looked into from the basic assumption that atom like something that exists from here we are till the Bohr atomic model. And moving forward, today we're looking into the further story, like what got happened after the discovery or the the you can say that showing of the representation of the Bohr atomic model. So after this, what got happened was uh, like people got to know that basically, let me draw a prism over here. People just observed these things from the Bohr atomic model and just linked these things to the Bohr atomic model. What things was like, we do draw a sun here, draw a sun here like this is our beautiful sun. Yes, this is the beautiful sun, and these are the rays of the sun, right? So few at the back. So when these rays of light were passed through the prism, like what got happened, like when these rays were passed through the prism, what got happened was we have just here is a photographic plate, like this is photographic plate pp, that means photographic plate, p and p, photographic plate. So what got happened was this, like when this got when these uh, passed through the prism, we got lights that went straight over here, and this was covering the whole section, like there was no break, no any sort of these light covered the whole photographic plate, like there was no any sort of space between some sort of darkness space between all this. It was all got covered, and we do got to know that this was in various colors, like let me draw Vibgyor over here, V I B G Y O R. This is Vibgyor, right? We have got 7 different colors from this prism, right? Light splits into its components, and this is called as the light passed into the prism. Like this is called a spectrum, which got found over here. So what we got observed, like this was the visible spectrum. I'm just writing the short forms of what I'm saying. You need to listen and just write that into your notes. You need to write full forms, but I'm just doing that as short form. Like we have got a visible spectrum, and this visible spectrum was continuous. Continuous. CON means continuous, and there was no breaks in between them. Uh, the wavelength, we have listened this in pure class. Like wavelength is in a form like the wavelength is at violent, that is 400 nanometer, and here it is 700 nanometer, and it if we talk, this is a visible spectrum, and we have got surprisingly we have got 2 invisible spectrum, like from here to here and one from here to here, which was not visible on this screen because they're not in the form of particles. We can say that they are not forming any sort of shades on the screen. So these are the 2 invisible. IS means invisible spectrum. IS, invisible spectrum. So these were like the wavelength got decreased from here to here, so this means they have short wavelength. I'm representing wavelength with delta, lambda, so short lambda, and this is high lambda, like they're increasing from 700, they kept keep increasing downwards, high wavelength lambda, high lambda, h lambda, and this high lambda region is the infrared rays, infrared rays, sorry, infrared, I'm writing I dot r, that means infrared rays, sorry. Yes, there are also others, like here in this section, uh, the one which are less than 400 nanometer wavelength, that would include the UV rays and the microwaves and all that. UV rays, UVR, right? So I do hope that you got cleared that when the sunlight is passed, we get okay. So let me tell you a point that the invisible spectrum are also the uh, continuous spectrum. So we have got three continuous spectrum. And why is this continuous? Because energy is being transferred completely. You know, the sunlight energy is being splitted continuously. There is no any break in the sunlight. It is a continuous flow of energy. There is a continuous flow of UV rays or sunlight from the sun. There are no breaks, so we have got continuous spectrums. Likewise, if you talk about non-transparent medium, yes, here we have taken prism, but for suppose we do take any element over here, like I've taken over here, for suppose this gray carbon. This is just an example. Okay, so this is the carbon I have taken from here to here. This is the carbon I have taken, and what will happen is, if I will pass sunlight through it, this is the same case, just we have replaced the medium. I need to draw my sun with yellow color. Oh my god, why is it not happening? I did want to choose this. Let me change the color. Yes, now it's good. Like this is the sunlight again, but you will feel some changes. What will happen, like these are the rays. This is a beautiful sun this time, isn't it? Do much in the comments. So if we pass the rays, like these rays to go over here, 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 and shockingly things get happened, like some of the energy, some of the rays get blocked. Like this is a non-transparent medium, so some rays get over here. Yeah, I'm unable to choose my change my pointer. I don't know why, but I'm unable. So like this, some energy gets trapped into the element, and what happens further on is, like we do get energy, like this much energy is here, but now we have got sorry, so here we have got the energy, but in large breaks. Like this is a great gap, a big gap. Previously that much lines, now only 3 lines. What's the reason behind that? We've got the photographic plate over here like this. Sorry, I don't know why this is happening. So this is the photographic plate, right? So what happens is, like we have got very few lines, only 3 lines, so this is not continuous. Okay, so let me show you a gap between them. Like here is a gap, here we can feel this is a gap, this is a gap, and in this there would be gaps. Do remember, in this as well there would be gaps, like little bit would be captured. And you will notice that what will happen is, like this would be this as you know that this is a spectrum that is formed in the result of the absorption of the light rays by the element, as this is the non-transparent medium. So this would be the absorption spectrum. I'm writing A dot S. You need to remember that this is absorption spectrum, and the spectrum which did formed over here is the emission spectrum. Like this is the emission, like the one has passed through the absorption, and the result of absorption spectrum is the emission spectrum. So moving forward, I need to tell you that there are breaks. These are not continuous. Like this is not like this. We have got hole in this region. We have got hole is covered, but in this we are having gaps like this one. Yes, this one and this one. So these both are absorption spectrum, and emission spectrum are both kind of non-continuous spectrum. Non-continuous spectrum, NCS. That means non-continuous spectrum. So we have got some sort of information that elements are non-transparent, they do capture some sort of light, and we have got two different spectrum. We get to know about some sort of light. This is non-continuous spectrum is also termed as line spectrum. Do remember, this is an important point, line spectrum. So we get to know that there is a line spectrum, something existing in the world. So there's a very important discovery in the discovery of the orbitals, the orbits, basically the discovery of the proper energy in the orbits. This got happened due to the hydrogen spectrum. We took hydrogen and did the same phenomena with that. So what did we found was, like, let me mention the topic over here. Hydrogen spectrum, right? So we did got hydrogen spectrum, and what was the result when we passed the light? We have got different sort of series. Like let me draw a diagram to show you that. I'm just doing it direct so that you can you have just do look that we have did the same phenomena over here. The light source can be like, we can take another sort of life, but that would be around the same what we have did. Like this is yes, this and this, and over here we've got 1 2 3 4 5 6, and this is visible. Like there would be three sort of UV, visible and invisible. All three sort of lights would be there, but we did have seen something like this is the first energy level. This is K. We have got to know that KLMNOP, this is something with definite energy is existing. I'm just writing previously, but this was discovered in this KLMNMNOP, right? So we need to consist we have got the ground state of the hydrogen. Like this is the ground state of hydrogen. This is kind of the ground state of hydrogen. This hydrogen atoms are there in the ground state. Okay, so what will happen is when the energy is given, let me draw some sort of fire down over it. So here is the light, here we have got the fire. This is a flame, like a large flame over here. Fire, F for fire. You did a heat energy, we have supplied some sort of heat energy over here, and the hydrogen atom will excite following the Bohr atomic model. Like as he stated that from the ground state, this is a ground state, from here the electron will be jumping into higher energy orbits. So we did got to know that what are these energy orbits, what is the energy in them, what is the wave number, wavelength. We got to know the properties when we did the hydrogen spectrum. So when the energy is supplied, what happened is, let me make you simple a bit for you guys. Like sorry, okay, so from here let me draw some sort of thicker one. Okay, so this is for suppose the when the hydrogen will excite, it will go to this level. Like this is the highest energy level which we discovered. From here, uh, this is the highest energy level. We got to know that this is the highest energy level, and this we named as, for suppose, this orbital. This is, I cannot say that this is the p which is highest energy because we have got a lot of orbits. This is just the highest on which the hydrogen went. And we did notice that we have, as the Bohr has said, that they do come when they got excited, they come into their ground state. When in the they have the wish to get stable, so they do this, like this will come behind, right? So uh, let me draw this one from this, and what will happen is this will go till this level, and some energy will be released. Like this is energy, and there would be a gap on this level. Like electron will take a gap on this level. There would be a gap on this level, and we name this small gap. Like we did got to know that there is some sort of gap while returning to the ground state. Some hydrogen atoms were on this state as their they got de-excited, they got to this place. Some got this, some got to the L, first L field, then M field, then N field. We're looking into that. Like next, for suppose this is the next. So from here coming back downwards, like here energy again got, like there is a break, the point I, K, L, M, N, O. So this is O, right? So the point O is the gap at which there is some sort of gap observed. Like there is a gap in the energy releasing. Like here energy stopped. There is some sort of little bit stability over here. So this same got happened over here, and we just got the properties of the N orbit. So same continues till the ground state. So this depends on which level does the electron falls. Like I'm just going directly to this, and there are three different levels over here, and energy would be emitted in the three states, and the final destination would be here. When this will get filled, then they will go on this, then this, and this is what's happening. So this is very, very, very important. Hydrogen spectrum really very important. We got to know. I can clearly, I do hope that as a student you have just observed that we have got to know something new, and this is because of this hydrogen spectrum. So this is very important. I do hope that you got clear the lecture. I would want to state it that this was the visible spectrum. We have did this, like we have got different series, we acquired different series of wave number. Like these all have got their own properties. Like this has own, this has own, this has own, they have got their own properties. Like every break, every energy level is different, and they have got different levels. So we have got there is a scientist, maybe Bohr, I'm not confirmed, he just calculated the number of wavelength or the energy in them by giving his formula, and just he classified this into that. Like he just classified the visible do come under Balmer series. He just gave different series. This come under Balmer series. This was one of the first series that got discovered. Next we have got the invisible, like it was of like maybe this, I'm not confirmed, I'm not going into deep because this is not of your level, that is not including your syllabus. We've got different levels, Balmer series, Balmer series. We just calculated like this is L dot L, L dot S. So this is we did calculated the number of wave numbers of these different energy levels, and we got to know that K, L, M, N, O orbits are existing. Firstly, we got to, from the board we got to know that there is some sort of orbit. Like we didn't know any properties of them, how many are they, or what sort of differences are they having from one another. We just got cleared, and this is very, very, very important. So in today's lecture we did look upon spectrum, like from this will of course continue, the series will continue. I do have just enjoyed today's lecture. So meet you guys in the next video. Till that, goodbye.